Welcome to lesson 1.2.3. What do they have in common? So glad you're here, and I hope you enjoy this video. Okay, so there are many questions that are asked in this first question on 1-98. And so we're just going to kind of talk about a bunch of them as we're going through this. First, the first question says, what do x and f of x represent in the function? Well, x is your independent variable. F of x is similar to y. So if I was to come here and change it to y, it doesn't change the graph, okay, if you can see what's happening there. But because it wants us to look at f of x, we're going to go ahead and change that to f of x. There we go. All right. And then also you can see in the table here, x determines the y. X determines our f of x. So every time I put something in, it's -2. You put that in, it equals -1. And I can go all the way down all these values. The other thing that you need to pay attention to here is they want to know what m and b are. Well, m is talking about our slope. So this is 2. That means we're going to rise 2 and we're going to run 1 every time on this particular slope. But where do we start? That's where we start with 3, which is our b. And so if you look over here on this graph, I have at 0, 3 is our y-intercept. And if you notice, I'm going up 2 over 1, up 2 over 1. And I could add another point here. So what's that one? That is 2, which is already there at 7. And then I could go to 3. And if I put in 3, it's going to go up to 9. And you can see where I'm doing that. And that is what each of those parts are of the graph. So you have the independent variable, you have y, which is the dependent variable, you have 2, which is your slope that tells you how much you're going to rise and run on each equation, and then you have 3, which is the y-intercept. Okay, now I've shown you how all of those are laid out, but let's say I want to add another equation, but I want the same slope. I'm going to have to say g of x here because Desmos won't let me graph two f of x equations. So we're going to say 2x, or actually 3x, wait, is that what we want to do? I want to do 2x, yes, and change the y-intercept. So 2x, and then I'm going to change and add it to 5. So the only thing that is changed here is I have my y-intercept now is at 0, 5. Now if I want a table on this, I can come up here and hit table, and it will also do a table of points that go with it, okay? So that's what happens. Let's just do one more equation and we won't put the table in. Let's say h of x equals 2x. And let's go down to a negative. So we're going to go down to -5, okay? Notice here, now all we've done is change down to our -5 at the bottom there. So that kind of discusses what happens with our change in our y-intercept. But let's go back and let's close these. We're going to mute these for now. Let's see what happens when we change the slope. So I'm going to get rid of this one as well. Oh wait, I got to get rid of these tables. That's what we're going to get rid of. Okay. All right, so I have 3 equations there. Let's go back to the 2x plus 3. And then let's go and change the slope. So we're still going to be at 3. So I'm going to change g of x to 3. And then I'm going to change the slope. So this time I want to rise 3. I'm going to say 4. Rise 4 and run 3, or run 1. So let's take a look at what that looks like. So see the difference here. Let's change the color of the graph so you can see the difference. So the blue line is our 2x plus 3. And we've left our y-intercept at 3, which is what we're trying to do right now because we're just comparing what happens when we change the slope. Notice now, from this point, I go up 4 over 1, up 4 over 1. So that's what happens with the g of x there. Let's change it one more time. Let's put a fraction in here. First, I'm going to go back and put plus 3. But then I'm going to put a fraction in here. And let's put 1/2. Okay, and let's see what happens here. This is a little bit different look. So let's change it. Let's put a color in there. Okay, gotta let me go. All right, let's do, okay, good. It's in black, that's fine. All right, Look at the difference here. We still start at 3. It goes up 1 over 2, up 1 over 2, and you get the idea. So the y-intercept tells you where you're starting. The slope tells you how much you rise and run. And so we've shown you examples now of what happens when you change the slope and what happens when you change the y-intercept. And that is a good start for here. So at this point, you can see variables are quantities that can change within an equation, and parameters are static within one equation but can change in other functions as well. All right, let's examine each group of equations below and think about what you would see if you drew the graphs of the 4 equations on one set of axes. Write a description of what you imagine you would see. The first thing I noticed on these equations is this particular equation and this equation have the same slope. So I'm kind of wondering if the others would have the same slope. Well, if I divided everything here by -4, I would also have a -1/2 slope, so that would be the same slope. And then if I rewrote this in this first equation in y equals mx plus b form, I would subtract the x, and then I'd be dividing by 2. And so I'd have a -x divided by 2, which would be a -1/2 slope. So yeah, I think I'm going to have all of the same slope. So I think I'm going to have lines that are all parallel to each other. So let's take a look at this graph. I am completely correct. And what's nice about Desmos is you can actually type this whole equation in as is, and it will give you the line. You can also convert it to y equals mx plus b form, because if you're using a Texas Instrument calculator, you need to put it in y equals mx plus b form. But this kind of gives you an idea of those particular lines are all parallel, so they will not intersect at all. And let's take a look at the other set of equations. Now this one's a little different. They've got multiple equations in standard form, and if you end up moving them over, you're going to find out that they all have the same y-intercept. So if I'm looking at this one, I see this one's going to have the same y-intercept, and I see when I move all of these over to y equals mx plus b, that's going to be my y-intercept. If I move 3x over and then divide by 4, I'm going to be dividing by a -4 on the 12. That's going to give me a -3 as an intercept. And then if I move my x over, I'm going to have -15 divided by 5, and that's going to be a -3. So I have a feeling I have all of these equations at the same y-intercept. So let's take a look at that. Okay, yep, I was correct. So take a look at all of these lines, and notice I just typed them in as they were given to me. And you can do that in Desmos. And then I also changed all the colors so that the equations went with each line. All right, and that pretty much tells you that. So the first set of equations, they have all the same slope. You can tell they are all linear because they are either in standard form or slope-intercept form. And then the second set of equations, they all have the same y-intercept. You can tell they are all linear because they are either in standard form or slope-intercept form as well. And that ends this particular problem. Okay, so 1-100 has A through F, which are 6 representations of a relationship between input and output. If you were in class, you'd be working in your groups and discussing whether each one of these is linear. And then you'd write a clear summary statement justifying your decision. If the relationship is linear, graph it and find its equations. If it's not linear, describe the growth. So let's just start by looking at part A. All right, A has pieces of bread as its X and grams of fiber as its Y. If you notice, each Y value, for every X value, Y is going up 5. So to me, that is a linear equation for sure. So let's just take a look at the graph. So I plotted the points, and it looks linear to me, and it looks like it has a slope of up 5 over 1. So I'm going to write an equation for that, which would be Y equals 5x. Okay, that kind of ends the discussion on this one. This was pretty straightforward, pretty simple. So let's move on to the next one. Okay, so for part B, this scenario is Killer Fried Chickens charges $7 for a basic bucket of chicken and 50 cents for each additional piece. That to me sounds linear just from what it's talking about. It starts at a base of 7 and adds 50 cents for each additional piece. The input is the number of extra pieces of chicken ordered, that's your X value, and the output is the total cost of the order. So that one is just plotting a points and setting up a table. So I will go ahead and show you that. If you see the table I put here, 0 is 7, 1 is 7.50, 2 is 8, 3 is 8.50, so it's going up by 50 cents each. And that looks pretty linear to me. So let's take a look at the graph and what equation I came up with. Hopefully you figured out that your y-intercept is 7. So it would be y equals 1/2 x plus 7, and that's your linear equation for this particular problem. And that is all we have on that one. Okay, so here's part C, and I'm looking at this table and I see it has 10, 0, and 0, 10, and it looks like everything changes by 1 point on each side as I go from the bottom up, but then I also see it 5, 5, so I'm suspecting that this is linear. So I'm going to go ahead and show the table, and it is linear to me, and it looks like my intercepts, x-intercept is 10, 0, and my y-intercept is 0, 10. And I also think I have a -1 as a slope. So I'm going to create my equation of y equals -x plus 10. And there you go. You have a linear equation, and there it is graphed. And that is part C. Okay, so this is part D. If you take a look at the graph, it's kind of difficult just from looking at the table to see whether or not it is linear. I'm not seeing any patterns there, so I suspect that it probably isn't linear. So the next thing I would do is plot the points. And what I can see from here when I plot those points is it looks like it might be an inverse linear. So I'm going to come up with what I think is an equation. Now, they did not ask you to come up with this equation, but I came up with this equation just because of what I know about this particular problem. So let's take a look at what my equation is. It's y equals 10 over x. So if x was 10 over 10, it would equal 1. If x was 10 over 5, it would equal 2. 10 over 4, 2.5. So that's kind of what I was suspecting. So 10 divided by 2 is 5. And seeing this pattern of points makes me think it's inverse linear. And then if I look over here, I see this as well with the asymptote, because I couldn't have 10 underneath here. I mean 0, because that would be undefined. And then also you see the second part of the graph that would show up here, but you didn't need to know all of that because all the points were just in here. But that is part D, and definitely not a linear problem. Okay, this is part E. We only have one more left after this one. And it says, James planted a bush in his yard. The year he planted it, the bush produced 17 flowers. So after the first year, he had 17 flowers. Each year, the branches of the bush split, so the number of flowers doubles. The input is the year after planting, and the output is the number of flowers. So I set up a table for this, and I put 0, 0, because obviously if the bush hasn't been planted, there's not going to be any flowers grown. But after the first year, he had 17 flowers. Second year, he had 34. So it looks like it could be linear here, but it doubles again. So it goes to 68 and then 4 to 136. So just looking at this table itself, I would say no, it's not linear. But I plotted these points just to see what it looked like. Definitely not a linear equation. It's exponential of some sort because it's not going up the same amount each step, each x variable. All right, that ends part E. Okay, so here's our last one for this particular problem. I am suspecting this might be linear, and part of the reason I'm suspecting that is it looks like I've got the same difference if I was to calculate slope. But let's take a look at what my points are plotted. Definitely looks linear. So now I've just got to figure out what do I think my slope is. So if I'm looking at the scale here, it looks like my y-intercept is at -7, and then 1, 2, 3, 4, 5 over 2. So it looks like I have a rise of 5 and a run of 2. So I'm checking this as well. 1, 2, 3, 4, 5. It runs 2. So it looks like my slope is 5/2. So I'm going to go ahead and now I'm going to come up with that equation. Let's take a look at what that looks like. And I'm correct. It is y equals 5/2 x minus 7. And so that is our last one of these A through F's. Let's move on to our last couple problems. Okay, without using a graph, decide whether the relationship shown in the table at the right, it's actually going to be lower right, is linear. Write a clear summary statement justifying your ideas. Be prepared to share your ideas with the class. I'm just going to share my ideas with you, and we'll talk about that in just a moment. Let's first look and see what our table is. Okay. The way I would look at this is I would take different points and I would try to calculate their slope. So if you remember the slope formula, it is y1 minus y2 over x1 minus x2. And it doesn't matter. You could put y2 minus y1 over x2 minus x1 as well. But this will equal the slope. So I want to figure out if they all have the same slope, because that's going to help me determine whether they're linear. So I'm just going to go ahead and put together a couple equations and calculate slopes. So I'm going to start with 0.5. Let's just start with -7 minus 4. Oh, sorry, it's not -7 minus 4. Let me erase that. So we're going to start with -7 minus a -22. Okay, then I'm going to put the corresponding x's. So 4 minus 10. This is going to equal a positive 15 over 6, which reduces to 5/2. Okay, so, and actually it should be a -5/2 because that's a -6. So we're going to have a -5/2 slope on that particular point. All right, the next set of points I'm going to use, I'm just going to go ahead and use the 0.5. So 0.5 minus a -34.5. Okay, and then I'm going to put a, let's see here, then it's going to be 1 minus 15. Okay, so that ends up being, if I do a 0.5 plus 30, that's 35 over a -14. Okay, and if I reduce that, it's also -5/2 because 7 goes into both. Remember, on the Texas Instrument calculator, you can type the fraction, so type the fraction in. Okay, then you can hit the math button, and when you do that, a menu comes up and you can pick fraction. Okay, and then you're going to hit enter. And that will show you that a -35 over 14 equals a -5/2. That's just a little tip for a Texas Instrument calculator. Okay, I have now shown that they both have the same slope, so I'm pretty sure that I have a linear situation. So what I'm going to go ahead and do is I'm going to try to come up with my actual equation. So I'm going to say y minus y1 equals m, which is our slope, times x minus x1. This is called point slope form, because as long as you have the slope and you have a point, you can come up with an equation. So let's take a look at this. So I'm just going to pick one of my y's. Let's just pick -7. So I'm going to say minus a -7 equals our slope that we calculated, which is -5/2, times our x value subtracted from x. So our x on a -7 is 4, so x minus 4. Okay, I'm going to make this y plus 7. Then I'm going to distribute -5/2 x. And when I multiply that, that's going to be plus 20 over 2. Okay, because a -5 times a -4 is a positive 20 over 2. So then it's going to be y plus 7 equals -5/2 x plus 10. And then all I have to do is subtract 7, and I have my linear equation, supposedly. So let's see what happens. -5/2 x, and then that's plus 3. So I'm pretty sure this is our equation. So let's take a look at the graph that I came up with. This is going to be one of those videos you're going to want to go back and look at and see what I did. And you might even want to take a couple more points and figure out if -5/2 is still the slope for those and check it out. But let's take a look at the table that goes with this. Okay, you can see that I have the points plotted. Okay, you can see that +3, even though I've got the scale here at 0 to 10, that's where our intercept is, and it covers all the points that are in our table here. They're all plotted here, and so my equation is right, and we do have a linear situation with this table. That is how I calculated it, and hopefully that helps. Remember, this point slope is awesome to use if you have the slope and at least 1 point, because it's going to help you figure out the equation. And we're moving on. I think that's pretty much it. Thanks so much for watching the video. We covered a lot of material today. If you have any questions, just leave them in the comments below, and subscribe and give me a thumbs up if you liked it, and we'll see you next time. On to the next video. Take care. Bye.